Honors Algebra 2. We are going to see if we get through 1.4 and 1.5 really quick. Yesterday we did 1.3 solving linear equations. 1.4 is how to rewrite equations, how to isolate or get y by itself, and how to solve formulas for a given variable. So some of it's just terminology what I'm asking you to do. So here it says write k in terms of m. You need to know which variable does it really ask you to get by itself, and you actually want to get k here by itself. You want to isolate the k. And I could write the same thing. I could even say write in terms of m. And that still means that m, when I get done with your equation, you're going to have a bunch of junk here. And m is going to be somewhere in this problem, and then you're going to have some other variable by itself. So it doesn't even matter if I have that what you're isolating in the statement. So why isolate certain variables in a formula? If I have a distance equals rate times time, and you collect a bunch of distances, a bunch of time, you don't want to plug them into this equation and then divide every time. So you can actually isolate for the rate first if you're trying to solve for the rate. So you know, oh, I need to divide, and just divide the numbers. So when it gets more complicated, it will help you solving for it first. Sometimes also about changing it to a certain form if you want it in slope-intercept form. So when you are trying to isolate an equation that has many variables, you always want to start far away from the variable. So if I make one up here, so let's do 3x minus 2 times 4h plus 3m equals 7x minus 5 times 2h minus 2m. So I have some variables there. Using a lot of our simplifying first, I'm still kind of following the framework for solving from a previous section. And I'm going to distribute here. And then I also need to simplify on this side, so I need to distribute here to make sure I distribute a negative 5. Now, when I'm trying to isolate, if I want to isolate, if I choose the variable, let's isolate our h. So if I want to get h by itself here, I'm looking at these h's, and I want to put them on the same side. I don't really care. The rest of this stuff here is some substance. I just want to get rid of it, get it away from the h's. So let me first put the h's on the same side. So then I have 3x plus 2h minus 6m equals 7x plus 10m. Now I just want to get rid of the stuff around the h, away from it, and I start farthest away from it. So let's subtract 3x to both sides. And I can do more than one step here. I can also add 6m to both sides. So that's going to get rid of those terms. So I only have a 2h. I'm left with 4x plus 16m. And the last step would be divide by 2. When I divide that by 2, I will find that h actually is, I can reduce this 2 going to the 4 and the 16. So I'll have 2x plus 8m. So I don't have like a statement or a value, I have an expression left over. So I don't care what's over on the right hand side, I just care that h is by itself, just isolating h, that's all we're doing. 1.5, we did 1.4, rewriting equations. 1.5 is problem solving. Can you write expressions and equations for a given situation? And we're going to work on that within each lesson, but we need to talk about some of the framework of setup. So when you're solving word problems, these are steps, kind of generic steps. A lot of teachers say reading the problem to get the idea, rereading the problem to find the question. What the question helps me a lot. A lot of times the question will tell me what the variable be. Circling the question helps me focus on that, helps me look back to make sure I've answered it. Scratching out the distracting information. And I'm going to add more of this than I have in the past to really push you a little bit. Underline the important information. Change words into their mathematical meaning. And that's just something students struggle more than they think they do. And then you can actually start solving this mathematical framework you've created. And so that's kind of a process. So the mathematical meaning of these words, do you know what they mean? So go ahead and pause the YouTube and try writing down as many other words that mean addition, subtraction, multiplication, division, and so forth. So pause it for a second. When you feel like you've gotten enough written down, then we can actually see how many of the ones I have you have. So here are the addition ones. I'm going to pull these up, and you can kind of compare how many of these that you got if you really did pause it and test yourself. Do you know what these mean mathematically? This is what a lot of students may not. It's like if I go to a foreign language class, I don't speak Spanish, and so I only know a very few words. And so if I go in there, I have no idea what's happening. The same thing happens in math class. A lot of students not quite sure what happened because they don't know what the words mean mathematically. So addition, sum, total, plus, increase, gain, raise, more, combined together, they all are ways of saying add the numbers together. Subtraction, difference, minus, decrease, loss, less than, fewer, take away. Less than is different than is less than. Two different statements here. And multiply, product, times, double, twice, of, and you can do triple. And so there's very values. Times and double is just times, or double and twice are just meaning that you multiply by 2. They're very specific. Division is quotient, divide, per, out of, ratio, percent. Percent is per, so you're dividing by 100. Equals is, are, was, were, yields, gives, will be, any form of that. Grouping, quantity is used a lot there for grouping. Now, the word and is kind of a tricky one because and is attached to an operation. So I have an example of this. If I say the sum of 3 and 4 times 5. So if I'm doing that, the word and is telling me where this operation occurs. So and tells me two things. Where am I actually adding, and that I have to do this summation then times 5. Because what I'm actually want to multiply is the and, the connection of these two times 5. So if I change this to mathematical meaning, it's really 3 plus 4. I want to do the sum of that times 5. So that summation is going to be times 5. I did not need those parentheses in there. So 7 times 5, or 35. So and is a little different. It could be with any of these operations. Inequality. Now you see the word less than again, but it's got to have this word is less than. So it kind of matches the is here as equals, and then is less than, is greater than. The word is actually the verb. It creates actual sentence, a mathematical sentence. So an equation is really kind of a sentence, kind of connecting English to the math language. So we need to know what these mean and how to change them in word problems into mathematical symbols. So example here, a pencil and eraser together cost 95 cents. The pencil costs 45 cents more than the eraser. Find the cost of the eraser. So the cost of the eraser, that's what I'm trying to find. I don't know what that is. So E is the cost of the eraser. So I am defining my variables. Now is there anything else I don't know? I don't know what a pencil cost either. I'm not quite sure what a pencil costs. But I do know that pencil and an eraser cost 95 cents. So I'm just kind of changing this in the mathematical framework. So P is the amount of the pencil. And again, the and is telling me where the operation occurs. The word together is telling me to add. So P and E cost, which is the equal sign, 95 cents. So that sentence right here, this sentence is an equation. So it should be pretty easy to write that down. The pencil cost, so again, the pencil cost 45 cents more than, so all I'm doing is changing the symbols or the words into the mathematical symbols. 45 cents more than the eraser. So now I actually have two kind of equations I'm dealing with. Well, instead of writing P up here, instead of writing P right here, I know that this P is equal to this statement. So why don't I put it in here? And those of you that recall systems of equations, that's really what this is. So this is the same as a pencil. That pencil plus an eraser is going to cost 95 cents. So there's an equation I can solve, combine like terms. And then I can solve that. So 2e is going to be 50 cents if I subtract 45 cents to a side, and then e, the eraser, is going to cost 25 cents. And is that what I want to find? Yes, I want to find the cost of the eraser. So I know that that is 25 cents with units. See if I can get through one more here. So you're saving money for purchasing an iPod. You have $89.94 and the iPod costs $369.94. If you're saving $40 a week, making $5 per hour, then how many weeks will it take until you can buy the iPod? So let me actually have you try this in class. I want you to come up with a question. I want you to try going through the steps, circling the question, getting rid of the distractors, trying to change the words in mathematical meaning, and then solve that. So I'll show some of that work and have you turn that in beginning class tomorrow for your problem. And that's what we've gone over. 1.5, we just finished that. Tomorrow, 1.6, we'll look at linear inequalities. So now we'll bring in the less than, greater than symbols within inequalities and how we solve. So we'll see you tomorrow.